Hello and welcome back to Tea Time with a Technology Advisor. Hi, Scott.
Hi, Karen. Looking forward to another tea time as usual. And I brought my minimalistic Alcatraz teacup today.
Okay, minimalistic. I like it. I have a Yeti teacup because I'm getting over a cold, so not very exciting. But
Excellent.
next time I'll try to up my game. So far for our tea times, we've discussed some common questions related to desulfurization and primary reforming. Today, I want to talk about secondary reforming or autothermal reforming, ATRs. Some of the main parameters that we monitor for secondary reforming or ATRs are methane leakage, DP, and temperatures. What does monitoring these parameters over time tell us, and what are we looking for?
Well, all things being constant, methane leakage is really the primary and first indication of performance issues that you're going to get. It's going to indicate problems such as poor burner mixing, channeling, or reduced catalyst activity. I've often seen plants go up in rates, but the burners aren't designed or maybe weren't evaluated for those increased rates. And as a result, there can be poor burner performance at the higher rates, and it can also be the case that there's insufficient loaded catalyst volume or activity, depending on how big that rate increase might be.
It is important. That's a good little PSA that if you're bumping up rates to try to make sure, and it's hard, but look through everything that you can, including the burner, to make sure that it's capable and it'll still perform at these higher rates. What about DP monitoring? Like typically we don't see end of run for these reactors due to activity, but it's usually pressure drop. What does the pressure drop come from?
Yeah, no, that's correct, Karen. Pressure drop buildup usually comes from either fusion or erosion of the catalyst, and most often that's related to poor combustion zone mixing due to burner operation, not surprisingly, or high rates and velocities. Things like temperature excursions from startups, shutdowns, and trips can also cause breakage of material, leading to DP buildup. Just as an additional note, if you're looking at increased methane leakage, you do need to understand that it can also be the result of what's happening even before the gas gets to the secondary or ATR. And you need to do a good first check of the entire process for other potential changes. And that includes things like changes to the inlet temperature, feed methane levels for the primary reformer, since those are going to impact the overall heat balance and then in turn the exit temperature and the methane leakage.
Awesome. Thanks for sharing. I also want to mention, I mentioned that end of run can often come from DP, but it doesn't always. Sometimes everything's fine. The catalyst is fine, and you don't need to get in until you do a vessel inspection, for example. So it's not always DP.
Very true.
All right. Cheerio, Scott. Until next time.
Cheerio, Karen. Have a good day.
Bye.
Bye bye.